On March 2nd, 2015, Paul G. Allen and his research team found one of the last great undiscovered wrecks of World War II off the coast of the Philippines. The IJN Musashi, 863 feet long, 73,000 tons, 1 kilometer down. It took 8 years of research and 3 expeditions to uncover her resting place. Working aboard Mr. Allen's MY Octopus with AUV and ROV technology, the crew will survey the great battleship. Join them live on an exclusive ROV tour. Experience the Musashi Expedition.
2, 1, live.
Hello and welcome to Motor Yacht Octopus. We're here in the central Philippines in the Sibuyan Sea. I'm Rob Kraft. I'm the Director of Subsea Operations for Vulcan. With me is David Mearns of Blue Water Recoveries. We're here in the ROV control room. This is Scott Matthews. He is our pilot, and Paul Mayer is our co-pilot. We're going to give you a tour of the wreck of the Japanese battleship Musashi. All right, Scott, let's go ahead and move in.
Okay.
Man.
ROV is live.
So this is the bow section of the wreck. We're coming into the port side. This is torpedo. Yeah. And what we see here in front of us is torpedo damage.
This is about the level of the #1 main gun of Musashi, and she was hit over the course of the day about 4 times with torpedoes here.
Okay, so we're going to make our way forward up towards the bow.
The torpedo penetrated the unarmored side of the ship and actually explodes inside. That's why all that hull plate was bent outwards.
Okay, we should be coming up to a near miss up here. Is it down a little bit? Might need to get down just a little bit, Scott.
So over the course of the day, on October 24th, 1944, the ship was attacked in 5 or 6 different ways of U.S. aircraft.
Mm-hmm.
And in addition to the torpedoes that hit and bombs that hit, some near misses also caused quite substantial damage, and that's what we're looking at here.
And so everyone understands a near miss is not a direct hit on the ship. It's a hit close to the ship, and it's the concussive force adjacent to the ship that creates the damage.
That's right. These were U.S. forces were dropping 1,000-pound bombs, and so the force of that exactly depressed all this plate upwards into the ship, and ultimately the entire port side bow was flooded.
So throughout the program, we're going to be answering questions from social media. And the first question we have is, to the extent you intend to look for other World War II wrecks, how deep can your ROV descend? So our ROV can dive to about 3,000 meters, or about 10,000 feet deep.
So this is a small buckle here, which would have been caused when the ship impacted the seabed.
So we're still moving forward. We'll be coming up to the bulbous bow. So this is the bulbous bow of the ship, the foremost part of the hull. So we'll ascend here and go up to the top, where the we'll see the chrysanthemum.
Even though most of the bow was flooded, there were some watertight compartments forward that weren't, and as the ship sank very quickly, these imploded, and so that's what we'll be looking at now. It's like sucking on a straw and squeezing all the air out of it.
So here's a great question from Reddit. Did you see the ship's bell or the Imperial Chrysanthemum seal? What was their condition? Yeah, so as we're ascending up to the bow, we're going to see the chrysanthemum on the bow of the vessel. Now, the actual chrysanthemum itself was made out of teak. I think it's 1.2 meters in diameter, and we'll see its condition up here. There's not much of the teak left, but it's very obvious that it was the Imperial seal.
Warships generally don't have their names, so the only way we could really know for certain this was Musashi was by the chrysanthemum, and this is the Imperial seal of Japan. That was only on the largest of their ships, the battleships. 3 of them, Yamato, Musashi, and the Mutsai.
Actually, are we coming up to where the port anchor would be first, Scott?
Yep.
Okay. And so Musashi has, or she had two 15-ton anchors. The one on the port side is missing.
And we saw testimony of the crew why it's missing late in the action when the ship was listing seriously to port. The only way they could correct it was to actually cut the anchor away and let it drop with the anchor cable, to think hopefully that would right the ship, but she capsized ultimately.
So here, just coming into view, is the chrysanthemum on the bow.
It would have been painted gold and really stood out, but after 7 years at the bottom of the Sibuyan Sea, the wood is almost entirely rotted away. But as we move in closer, you can actually see that the difference between the wood and the whole structure itself.
Okay, next we'll be moving down the starboard side. We'll see that the starboard anchor is in place.
That band of cables is a degaussing cable system to protect the ship from mines, magnetic mines.
Oh.
No, just one. One main one. One main one.
So here's the starboard anchor. We're going to move up to the anchor chain and we'll follow that aft. are you going to fleet down sideways and
Yep.
port? Okay.
So, do you want me to cross over or stay on this side?
I'd stay on this side, Scott.
Okay.
I can't read that. So here's another great question from Reddit. Was the expedition able to locate all 3 turrets? So during the expedition, we've only located to date one of the main gun turrets, the 46 centimeter or 18-inch guns. As we move aft on this, the bow section here, we're following the anchor chain down. We'll actually see the number 1 turret barbette, which was the base for the main gun that it sat in. So do we have the next waypoint set up, Scott, for
Yes, the ROV is currently tracking
possible? Okay. Gotcha. That's good. If we can get a quick look at the capstan there, Scott.
Roger that.
It was an electric capstan, actually.
Pan up, Scott, I'll kill the center light.
You can see the bows resting at quite a severe angle.
Ah. Okay. Let's go ahead and move on down to the barbette.
We haven't seen many fish, but there's a lovely one in red. A lot of deep water fish are red.
Do we have the barbette on
Just coming
sonar?
up with
Behind
sonar
this.
now.
Yeah, okay. You know, so we've had a lot of questions about the actual depth of the wreck. The depth varies depending on where you are in the debris field, but the average depth is 1,185 meters. Or in feet, that'd be 3,887 feet. Okay, so coming into view now is the number one main turret gun barbette. Now this is the base that the main 18-inch gun would sit in.
It's essentially a hole, and the turret, which weighs 2,700 tons, would fit in here. And we're just passing the forward section of the armor belt around it, and that armor belt was 56 centimeters, one of the thicker armors on the ship.
And the diameter of the barbette is 13 meters?
Approximately, yes.
And the turrets were held by weight alone, correct?
Correct, gravity. So when it capsized, this turret fell out. And the main guns are obviously what made Musashi a super battleship. They were 18-inch guns, bigger than any other in the world.
So pull back. All right, Scott, let's pull back. Let's get ready to get the ship on the move.
Right up.
Have the gearing.
Go. ROV control, MEC, you're live.
Okay, so we're going to pull the ROV and move to the next location. And during that time, because the transit is so long, we're going to show you some highlights reels.
Roger, Robbie.
Go on, Scott.
Stu, can we make a vessel move 250 meters, freezing of 4 degrees, please?
Copy that.
Is inverted on the seabed. We'll be coming up to the outer port propeller. Are you going to stay down here, Scott, and tilt up, or are you just going to come up a little bit? Roger. Yeah, this is the hull right next to the outboard propeller.
So the ship had 4 propellers, 5 meters in diameter. You can see that this propeller, the shaft is broken on this propeller. She's laying down. So what do we think may have happened to this one?
Well, it's either on impact. These ships hit the deep water like this. They're actually hitting the seabed at very quick speed, anywhere between 15 and 25 knots. So the shaft could have bent right at that point. It's also possible that the shaft could have been broken. We believe there's been a magazine explosion that could have happened. It's looking more like this happened on impact. It's just been broken and it's sort of extended out a little bit more.
The other blade's got is bent as well.
Right. Is a bit fractured, so that's a bit curious. I mean, this part of the ship hadn't been hit with torpedoes, so this isn't damage that happened during the battle. Possibly, it had a problem before the action, but it's hard to say at this point, separating the two possible events.
Okay, let's move into the rudder, Scott.
The propeller hub's intact, though. Oftentimes those are imploded on deep water wrecks. I think on hoods they were imploded. And this one's all 4 intact. She's well, this is the main propulsion. So it's a 150 horsepower ship, 12 boilers. Running 4 turbines, 1 for each shaft, and she could do a top speed was 27.5 knots, and that was a little bit less than what the Japanese had wanted. They wanted originally the ship to be able to do 31 knots. They were really keen for beating the Americans for speed, but in the trade-offs of designing the ship, it was ultimately decreased down to 27, 28 knots. And that's the auxiliary rudder. This is the smaller of the 2 rudders. This is forward of the main rudder. And this was also a different design. Most ships of this size would have 2 rudders side by side, but this one is this smaller auxiliary rudder forward.
Let's move back to the secondary rudder. What was her turning capability? Because I know that they said it was 1 minute and 40 seconds by the time that they turned the rudder before they saw some.
It was very good, exceptional for a ship of this size. It could turn. Its turning radius was something like 650 meters, which was much better than other vessels. And what they found out with this auxiliary rudder was that in a turn at full speed, the auxiliary rudder couldn't actually arrest the turn, so it wasn't doing exactly what they had hoped. But yeah, the ship was very maneuverable for a super battleship. And you can see actually these struts that are supporting the prop shaft, and that is quite elegantly designed. And the Japanese worked very hard to streamline this, which would increase. They would decrease the friction, and that would increase speed and improve fuel efficiency. And overall, the ship, They worked on the bulbous bow, they worked on this part of it, they worked on the shape of the vessel. So it was really an advanced design in a lot of ways. By the end of the action, the ship was down to just one rudder, and it could only do 6 knots. Sorry, one propeller, one engine. It could only do 6 knots and could steer a little bit with a rudder. And that's when actually the American air crews did the most damage to Musashi.
So this is the auxiliary rudder coming into view now?
The main rudder.
The main rudder.
Yeah. And she's much bigger. It's about, scale-wise, you're looking at 7 to 10 meters in dimensions. And Scott, if you come around to the left and look down the rudder, we'll see some of the damage that happened when it sank. It's really quite amazing that we're getting this view, because most of these ships, when you find them on the seabed, they're upright, but they're in the mud, so you hardly ever see this detail. But we're getting full view of her whole, all her rudders and all the propellers. Now the implosion damage is becoming really clear here. You can see the back edge of the rudder is bent, and that's happened with this implosion. So we sunk so quickly, this was an airtight space, that the pressure, while she's sinking very fast, and this happens in the first sort of 50 to 100 meters, squeezed all the air out, and the structure collapses on itself. So the skin, the outer skin, steel plate is actually shrunk over the internal frames.
All right, Scott, let's get ready to move, get yourself clear. We're going to make our way over to the bridge, superstructure now. And on the way, we'll take a look at some highlights.
Take some stills.
Yeah.
Okay. And I'm fairly stable. If you wanted to zoom in on anything, I can hold this, I think.
Hold on. I have a...
It looks like it was on the right.
There is writing on it. You
Yep.
can see it.
Yep.
It's characters. Get a bunch of stills of this, because it'll help identify it.
You can see them stamped on it.
Yeah.
It's like a cereal plate for something.
Yeah. So this is a piece that somebody else manufactured, and it needed a serial plate because it's a bit unusual.
Do you want to drop a Wimfrog waypoint?
Bigger than that, isn't it? Hold on. I have a...
It looks like it was on the right.
Oh, why can't it pan down anymore?
I'm B. There you go.
the detail, I mean, it's got the planes on it, and everything is like weathered.
Yeah. But we're sure this is not the same position as that previous one? Okay. So then I would say this is barbette number 3.
Or we can verify that because the positions are in wind frog, aren't they?
There's 2 more doors visible now in your floor fucking now. You see them?
Yeah.
2, 3, 4.
I've got some sort of plate behind me. Oh no, it's on top, isn't it? Up top.
I think those are, I think well, this would either be barbette number 2 or 3.
Trying to give you a bit of rotation. Oh, now I've got stuff in the back. Yeah, in front of me, big spike. Oh yeah. Come ahead.
Yeah.
Yeah. It's going to start to come up.
So do you think this is this inverted, David?
Yes. It's inverted, and it's so the turret fits into this, so the round bit, the hole, is called the barbette.
Yeah.
And what we'll do now is go have a good look around, when it appears to be another lip. Up towards the top, that means this is a warhead shell. That's definitely a 15.
Iris down. There you go.
Yeah, that's definitely a main gun shell.
Iris down. Main gun.
Yeah, because the banding at the bottom is made out of brass. And you can see it clearly here. I mean, it matches perfectly the photograph I'm looking at. Thank you very much. Yep.
Still not over far enough. Stay down, stay down.
So that has a projectile capture, correct?
Yeah.
Put that a little bit, so I get full frame. Oh wow. That's cool.
There, see, there's some writing right.
Yeah.
Oh, yeah. This will zoom in some more. Now I gotta focus.
Stay down. Hold on, I get right back to it. Oh, nice. Very nice.
Okay.
Wait until I... Okay, you can pull in now.
I just wanted to see what's on top there. See, there's something shiny on top of the door. Okay, I'm pulling.
Okay.
We're way too far. I'm pulling back for now.
Okay.
Till you get down and
Yeah.
situate yourself. And is that a tag? No.
That's big pedestal mount.
I'm just gonna mark the waypoint as pedestal.
Right now, until we know what, identify it more accurately. You can see all the electrical wiring coming out of the central hole. I mean, it's a heavy pedestal. But it's so that
So there are three distinct U-shaped features.
oh, there you go. Okay.
So what my question is, could these be part of, let's say, hold it there, whether it's upright or not, okay, could the top part
Yeah.
have been blown off, so the other section of the U where
It would have to be the inside. It couldn't be the gun house on the outside because that would be blown away. That's what we don't see. But that could be an inside part of it. But that could have happened there.
So we're looking at these three U-shape and this blown out, and then the top part is gone.
Yeah. Now I'll show you what I was referring to.
But that,
In fact, it is bent up. You can see it clearly that it is.
but that chain didn't go over this part of the gearing.
And that would mean that with this down, that gear would fit into the bar beds, and that would be the turning device.
So this is a blast shelter that we're looking at, and they were needed on the ship because when the main guns were in action, the 18-inch guns, the force of those guns being fired are such that, they actually could kill somebody. And early in the action that day, some of men on the deck were blown off. Musashi fired her guns. They couldn't get into a protected area, couldn't get into this blast shelter, and the men were lost overboard. So this structure on the right here was where somebody we believe this was an operational area, not just for protections, but they needed that protection as well. And to the left of that, the round structure that is quite damaged, and we can't really tell whether that was a gun emplacement or something else.
Could that would have been a base for one of the catapults?
No, the catapults are further out. This is really the center line of the ship here, and we're looking forward. So if you were in that blast shelter, you'd be looking aft over the crane deck and a central well.
Take some stills.
Yeah.
Okay. And fairly stable. If you wanted to zoom in on anything, I can hold this.
112. ROV is live.
Copy. All right, Paul, let's move in. Coming into view in just a moment is going to be a 15.5 centimeter gun turret.
The ship had two of these guns, one forward and one aft. We believe this is the forward one. Even though this is a secondary armament for a 6.1-inch gun. This would be about the size of a gun on the destroyer.
Which would be their main.
That's
main
correct,
armor.
yeah. It's a triple gun, but we can't see the barrels. They're buried in the mud in front of us here. Like the main guns, these were equipped with their own rangefinders. So at the top of the screen there, that object sticking out is one side of the rangefinder. This is, I believe, an 8-meter system.
So we think the armor has come off this.
It appears that, yeah, the top of it. We're looking now we're looking down on the top of it, and all of that ridging is where we believe they've hung the armor on it. Now coming to the back side, you can see the actual back armor is actually in place.
Turn the iris down just a little bit. There we go. Just about make out a little bit of the mechanism. There's a silver tray in there, and that would have held the shells before they were loaded into the barrels. Push in anymore. Zoom in. There you go. So there's two access hatches here, and there's you can see some of the armor plate still in place. Correct. We're just coming into view the ring that would be fitting around the barbette and the lower structures of the turret itself.
So this turret, like the main turret, was also just fit in by gravity, and it's come out when the ship capsized.
So, as a sense of scale, David, the barbette for this gun would be about 8 meters in diameter.
Something on that order, 7 to 8. Yeah, the full length of the turret itself is about 11 meters, so it's still a massive gun, but it just pales in comparison to the 18-inch guns.
Yeah. Let's see if we could come down, Paul, and have a look at the
Another
barbette
fish
down there. Yeah.
Another fish swimming by.
Yeah, we've seen a few of those.
There's the inner workings of the gun turret, just exposed there. Cabling and pipes. That section would have actually fit in the barbette hold then.
So many people are wondering about the imaging that we're able to provide here and the technology used to do that. And we have a broadcast quality high definition camera on the ROV. And so here after we take more of a tour towards the end, we'll bring the ROV on deck and we'll get to show you this technology. Okay, so where are we at on? Yeah, okay. So the ROV is going to transit now over to the bridge and the superstructure of the wreck. And during that transit, I'm going to go ahead and we'll go up to the bridge on Octopus and we'll have some discussion up there. MEC, ROV.
Go ahead, RV. We'll make the switch now.
Copy that.
Welcome to the Bridge of Octopus. We're live from the Sibuyan Sea here today. Great day, calm weather, only about 7 knots of wind, beautiful sunshine. My name is Yannick Olsen, I'm the captain of Octopus, and next to me here we got Stuart. Stuart, he's the officer of the watch today, which essentially means that he's operating the maneuvering gear today, and I'm overseeing the operation. This is quite a unique mission, as we have explained already. At the minute, what we have the ROV down at 1,200 meters below the keel of the ship, and basically while we are transiting to the next point, which is the superstructure of the Musashi, our job up here is to make sure that the ship follows the ROV. So from this point on, when really the ROV is calling the course we are going to when we go to the superstructure. It's very important that we continuously monitor what happens. We don't want to stretch the umbilical on the ROV. And also we want them to keep a straight course as they go over to the superstructure. It might be worth also just explaining quickly what an ROV is. ROV is short for remotely operated vehicle, and it's essentially a mini submarine, submersible, unmanned. There's nobody on board it. It's connected to Octopus with a tether, and that tether supplies the ROV with power. It enables us to control the ROV, and it also enables the ROV to send video footage, as Rob just explained, back to the ship, which we are then streaming to all you guys out there. It's an incredible piece of technology. Without an ROV, we couldn't do this. With a wreck at 1,200 meters, there is simply no other way, easy way to get down there and film it. So yeah, fantastic piece of kit. In order to be able to follow the ROV, we obviously need to know where the ROV is. And in order to do that, we have a piece of kit. It's basically a pole that we extend down towards the aft end of the ship. It's an acoustic tracking unit, and that enables us to, it basically calculates the position of the ROV in relation to Octopus. In order to illustrate that, we're going to go up to one of the screens we have up here. And at the minute, what you're seeing the outline of Octopus here. This is all GPS stabilized, so it's showing the real position of Octopus. The background is basically the bottom image we have from the AUV from an earlier survey. The little green dot here is actually the ROV. And as you're seeing here, we're moving the ship sideways at the minute, and basically just following the ROV. In order to do this, obviously we need great control of the ship, and this is where Octopus, she's equipped with some fantastic equipment. If we go down on the desk here, this is what we call our DP desk. DP stands for Dynamic Positioning, and easily explained, that's a system that automatically allows us to hold position as well as move the ship in a certain direction for a certain distance. While we do that, we can hold heading, we can do a lot of things. This system is phenomenal. It's got so many functions in it. And this is basically when we do our ROV operations, submersible operations. Stuart here behind me, the officer of the watch who is maneuvering the ship, that is basically where he spends most of his time. With this kind of equipment, it's obviously important that we have to stay on top of it. It's always monitored, even though it's an automatic system that can do a lot of things by itself. It still requires operator monitoring for safety reasons and ensuring that everything goes the way it should be going. The DP system, you can almost compare it to a basic, like it does the same as a human does. It's a computer that calculates what it needs to do in order to keep the ship in position. In order to do this, we've got wind input, we've got GPS input, we've got two kinds of GPS input, and we got a high level of accuracy on the DP system. At the minute, if you look at the screen here, we can see that we got 104 meters to go to the next set point. Once we come up to that point, we'll see that number decreasing, and on a day like this, we should be able to end up with somewhere between 10 and 60 centimeters of accuracy, which is incredible. So the DP system, if we go further down the desk here, what it does essentially, it communicates to our normal maneuvering gear. And what we have here, we have the telegraphs. The telegraphs control the main engines. On top here, we have the bow thruster. We got two tunnel thrusters on Octopus, which can push the bow sideways. Aft of the telegraph here, we got control of the stern thruster, which is an azimuth stern thruster, which helps us control the stern. And finally, and not least, of course, the wheel here, the old classic wheel. We can also control Octopus with our two joysticks here if we want to do that. We control the rudders individual. Heaps of options for us, basically. Everything the DP system does, we could potentially do that ourselves. We could maneuver all this gear manually. Stuart, myself, any of us could do that. And we would be able to do it. We just probably wouldn't be able to keep the ship as accurate in position as the computer does. So that's a really interesting thing to consider, that the computer actually does the station keeping better than a human would. Obviously, to get all this to work, we need power, we need engines. Up here in the bridge, we have a little bit of an overview of that, even though the control room is down on deck one, down in the bottom of the ship. We can look up at this, and this basically tells us, this screen tells us how much power we've got available. On Octopus, we've got 8 diesel generators, and they basically supply us with everything we need. They supply us with power for the propulsion motors, for lighting, for galleys, for the ROV as well. Basically, it's a little living town here. And as we can see up here, we're currently running 3 generators because we got quite a lot of propulsion gear online in order to keep the ship in station. Octopus as a yacht is kind of unique. It's actually very unique. There's not really any other yacht out there that compares to us. And there's a few reasons for that. Obviously, as a yacht, we're 126 meters long, so we rank up there with the biggest yachts on the planet. She's a fantastic yacht. She's got lots of space. We can do a lot of things with her. She's very glamorous. She's beautifully set up. She's a fantastic ship in that respect. What we have, though, that a lot of other ships don't have, a lot of other yachts don't have, is the whole research capability. And for example, that's something that's allowing us to do what we are doing right now. We have a 10-man submersible. We have an ROV, which I've explained already. We have an AUV. The AUV we'll show you slightly later in the show to explain what that does. And with all this equipment, essentially, we've managed to get where we are now, where we've achieved to scan the Sibuyan Sea and find the Musashi. Octopus has a crew ranging between 40 and 60 crew, depending on the mode of operation, which always changes for us. We're always busy to the next great mission. It goes without saying that it's an incredible experience to work on a ship like this, and especially now being involved in the Musashi expedition. There's been a really nice buzz around the ship. Everybody are really excited, and everybody is starting to get an understanding of what this great ship was and what she stood for. The Musashi itself was just an incredible ship, just like the Octopus was. She was first conceived in 1938. There was 2 ships in this class. There was the Yamato and the Musashi. She was 263 meters long, so one of the largest battleships at that time. One of the incredible things about the Yamato and the Musashi was that at the time of their build, they exceeded anything else that's ever been built. They had the best technology was available. They had the most power. They had the biggest guns. They had 46 centimeter guns at the time, and that's one of the things that's never been replicated since these ships were built. So they basically had the biggest guns made in history. The ship itself obviously is an incredible feat of ingenuity from the Japanese, but just as much the people that served on her, and that's something that's very close to our heart and very important for us when we are here. One of the reasons, obviously, that also Paul Allen wants to show this ship to the world is that there's a lot of remembrance in this, and it's important that we basically remind the whole world of what happened here in 1944. It was a dramatic day. It was all these brave men went through lots of hardships, and 1,023 people were lost. And that's something that both Paul Allen and us think that we should never be forgotten. In that respect, it makes us proud to be part of this. We think that we are conveying something to the world which is significant, and it also teaches the world about the past and what happened. Overall, it's just been an incredible experience for the whole crew. Paul Allen started this project 8 years ago, and it's just been an incredible thing to be part of. And we're very lucky here that we've put in the situation that we've been allowed to assist with such a significant mission. Next thing, we want to go over and have a look at the wreck itself. There's a few things we can learn from the picture of the wreck, which I'm going to show you now. The image we have here is basically the side scan sonar image of the seabed surrounding the wreck site, which we've captured with our AUV. And this actually tells a little bit of a story. I think the best thing is to start with what actually happened on the surface. The Musashi, a model of the Musashi here, was basically hit by a number of torpedoes and dive bombs all over the deck and on both sides. After the 5th wave of attack, she was in a really, really bad state. She was basically nose down, and she was starting to list to port. They did try to speed up to get out of the danger and get the ship away from the battle area, but what they found when they did that, she started turning and she had basically become uncontrollable. At that point, a lot of the crew was sent out aft to prepare for abandoning the vessel. as she took in more and more water, they tried to shift water from side to side to keep the vessel floating and stabilize her, which they didn't manage to do. She slowly leaned over to port, and eventually she basically slid down and sunk. At that point, it was dark. It was early evening. Quite a few people got off the vessel. What they reported as the vessel went down, there was a couple of explosions midship, and they reported fire over the water. Of course, as soon as she was in, that was the last one anybody ever saw of the Musashi up until the 2nd of March when we found her. If we now go over to the side scan sonar picture here, that's kind of interesting. We know she went down in more or less one piece, but what we can see when we look at the image is that we've got the stern here, and we have the bow here, which we've both visited. And you can see that they are pointing in different direction. So it's quite clear that she didn't land on the bottom in one piece, which is an interesting fact. When we move further up here, what we see a very, very large debris field, and we've spent 2 weeks going through this debris field with the ROV, and it's clear that the destruction is total. The amount of energy that broke this ship up is significant. No one can really for sure say when the ship broke up and how it broke up, but we know for a fact when it arrived at the bottom, the whole center section of the ship was destroyed. One thing we're going to go to next, once we finish up here, is the bridge section, which is a very interesting area to look at. And you'll see both bridges and all the details of that. It's one of the parts of the ship which is easily recognizable. So we're good. Yeah, let's go out to the bridge wing quickly and have a look at the ROV umbilical. So now we're in the bridge wing of Octopus. As you can see here, we can control the ship from the center and from either bridge wing. A good thing about the bridge wing is it gives us the opportunity to look down the side of a ship for docking, etc. What you're seeing right now is the umbilical for the ROV. This ROV goes to 3,000 meters, so you can imagine it's quite impressive. We have basically 3,000 meters of umbilical stowed in there. So with that, I'm going to be ready to send you down back to Rob and his team down in the ROV control room, and let's have a look at the superstructure.
ROV, MEC, audio and video live.
Copy that, Stu. So here we are on the superstructure. This would be the #1 bridge, or the combat bridge. And just to the left side of the screen there, we have the rangefinder.
This is a 15-meter rangefinder, identical to the ones that were on top of the main guns. And this is a low-angle rangefinder to be targeting enemy ships.
And this also was optical?
That's correct, yes.
And it also had some early form of radar?
Yes, the Japanese, later in the war, they fitted radar to Yamato and Musashi, and you can just see the footings of the radar supports to the left. The actual radar structure has been wiped away.
And so the main 18-inch guns, the range on those guns was 26 miles or something like that? I mean, it was an incredible...
Yeah, 42,000 yards, which basically means they could shoot over the horizon at enemy ships. We're at the very top of the superstructure here at what would be deck 11. The ship only had 7 decks from the main deck below, so it gives you an idea how high the superstructure went. The Japanese were famous for pagoda-style superstructures. This one's a little bit different.
Here's a very interesting question that we've got from Reddit, I believe. Are you worried about unused ammunition down there? Can it still explode? So I think we've, what we do see a lot of are the remains of the cordite that was used for the main guns. Now, from what we understand, is that can actually still be unstable.
Yeah, if you brought it up on deck, which is something we wouldn't dream of doing, then yes, you could. It could begin to cook off and react, the cordite itself. But no, they're just. This is the safest place for them to be now.
Yeah.
Hang on a second,
this is
pushing a little bit more. We can see one of the mounts here for binoculars. Get a bit closer.
This would have been the air defense combat post, and around the entire superstructure there would have been these mounts for binoculars for targeting incoming aircraft using the 25mm anti-aircraft guns. We're looking at the pedestal on its side.
Yeah.
That's the port side arm of the rangefinder. The starboard side has actually been sheared off, and it allowed us a unique glimpse inside the mechanism.
So from here we're going to go to the funnel. And David, do you think there was a chrysanthemum on the funnel as well at one point?
Well, it's recorded for Yamato that there was a chrysanthemum there, but unfortunately we can't see it here on Musashi. The funnel is really quite damaged, and it's really silted up in an area that the chrysanthemum would have been. A different design of funnel in that a lot of the pipes, the vent pipes, are on the outside of the structure rather than on the inside.
And straight ahead here, we're approaching like another, perhaps another binocular.
Well, I mean, in this area, it's either going to be a turret for a searchlight or another rangefinder, and it's really hard to tell because the cover has been ripped off.
So I guess we probably ought to tell everybody we're seeing a lot of these little creatures that come swimming by, and this is actually a swimming cucumber.
That's right, a holothurian. Yeah, so actually looking at that is the rangefinder, and to the left would have been the searchlight.
Ah. Yeah, that's good.
This open platform would have been a placement for a 25 millimeter anti-aircraft guns, and that's an unshielded platform. That's the windows there, just at the lower part of the screen. Under that platform is the compass platform, where some of the navigators would be.
Yeah. The compass bridge?
The compass bridge, compass
Yes.
platform, yeah.
So the number 2 bridge is, they also refer to it as.
Yeah, and you imagine how do you get up and down this 11-story structure, but they had an elevator through the center of it.
Yeah, I didn't realize they had an elevator.
This is where the bridge ends and actually is buried in the mud, and unfortunately we can't see the conning tower here, but it would be below us, just below and forward of that compass bridge.
Right.
Should go back up.
Up the others a bit there, Scott.
Good.
Thanks. And this is
So-
the back part of the, or forward part of the combat bridge.
That's correct.
So are we seeing damage here, do you think, David, from a bomb, or is this
Yeah, well,
maybe sustained in the...
we've been looking for bomb damage here. The Japanese said they took a direct hit from a 1,000-pound bomb here. The commander of the ship, Inaguchi, survived this. It's just hard to believe how he did that, but he did. That would have been one of approximately 19 direct hits from aerial bombs on the ship. Paul, can you push in on that hole there?
That's not what you really cool.
Yeah, go ahead, Scott.
We haven't seen this before, but that may be where the bomb actually penetrated.
Wow.
Musashi wasn't being fired on by any other ship, so that hole could have only have come from a drop bomb. So that must be the one that destroyed the combat bridge.
what is this we're looking at here?
This would have been part of this air combat platform, and just to the left there you can see again one of the mounts, the pedestal mounts for the binoculars.
Oh, okay.
This is detail that doesn't exist anywhere because there are no drawings left of the ship. And so we're seeing things for the first time. That's where the the right arm of the rangefinder is broken off. You can see the tubes, which would have been the optical connection to the mirrors on the side of them. The wreck is actually very damaged. We're showing you sections, but it appears that she suffered at least one, if not two, magazine explosions, which would have sheared off the bow and the stern. And this entire middle section, the superstructure, is the third largest area of debris.
Right, and to give everyone a sense of scale, the debris field spans about 880 meters from one end to the other. And the width is about 500 meters. So it's a significant area. Oh, so is that a triple or a double?
This will be a double. This will be one of the 12.7 centimeters gun turrets. This is also a rotating gun turret. You can just about make out the two barrels, and there's shutters on either side.
It's got three.
How about a push in, Bob?
Yeah, go ahead.
Look. 1, 2, 3.
Yeah,
That's,
you're right. It's
that's
looking
a triple.
It's not supposed to be in that location, but that does. Well, unfortunately, we're going with model of Yamato, which is different than Musashi. But
yeah, the armament changed throughout the years, didn't it?
that's correct. Yeah, and
So this is a triple. What size gun would this one be?
that's a 15.5 then.
Zoom into that hole. There's a couple of hand cranks there. That would have been used for the elevation of the gun?
And if they didn't have, if they were in local control, then yes.
Yep.
That's the main.
Yeah. No. No. No.
Yeah, see, that doesn't make sense. This is a 12.7. It's just
No.
because it has the shutters on the side. It just may be something else that's fooling us in that image. See, 3. Sorry, no.
Yeah, that's it. So it looks like a Type 96 25 millimeter triple.
Right. Okay.
Yeah.
Yeah. That's we've gone down a lower deck than we expected. So that's the confusing part of it. The shape of these turret houses is very similar, so you can be fooled easily. Okay, it's clear now. This is the one that sticks outboard of the main of the hull.
Yeah.
So this is the on the forecastle deck. This is a triple 25 millimeter anti-aircraft gun. No.
So what are we seeing down here,
Well,
right below that gun?
This wasn't on any drawings, but it's a little platform, like an observation post for looking aft. It's armored, and there are hatch windows that can be closed. Because the superstructure is on its side, it's really confusing when you're going forward or aft, and that's what's happened. We've got
definitely
confused there, so. There appears to be another binocular mount here.
Zooming on that, Scott?
Yep.
Oh yeah. You got any more on the zoom? Focus. Okay. You pull back a little.
Yeah.
That's pretty good. Yeah, that's interesting. I haven't seen it before.
Those are sections of armor that seem to be displaced from something. You can get a feel for the thickness of the steel plate.
Yeah, but pull in, Paul.
Yeah, go ahead.
Is that from the lasers?
Yeah.
Yep.
That has to be deck undersides then. So that's been blown upwards. But it's an armored, it appears to be an armored deck.
And how thick was the armor plating?
Well, it ranges for anywhere from 50 millimeters all the way up to 650 millimeters. The way these ships would have been armored, they would have been protecting the vitals, the engine room, the guns, those sorts of locations. Make sure the ship could fight and still move. This was the most heavily armed ship ever built, so it fits the name super battleship in every single way. Question from somebody on Reddit about torpedo damage. It's often been said that the weak joint between the ship's upper and lower armor belts made the ship excessively vulnerable to torpedoes. If you could see into any areas of torpedo damage where the outer bulge was ripped away, did you manage to see any evidence of the condition of this area? And this, unfortunately, was the most heavily damaged part of the section of the ship, and we didn't see these bulges, the torpedo bulges, which is sort of like a first defense. The sad truth of the loss of Musashi was that she was just targeted so thoroughly by anti-aircraft forces that no defenses would have saved her. 28 Japanese ships in this battle group. She was the only one that sank in the Sibuyan Sea. This was the lead-up, actually, to the Battle of Lady Gulf. So of the 28 or so Japanese vessels that were steaming to engage the American forces in Lady Gulf, Musashi was the only one that sank in the Sibuyan Sea. Because she was the largest ship, and also because she was hit and on fire, all the other aircraft just targeted her, and that was actually a mistake by the Allied forces.
So again, we are live here on Motor Yacht Octopus in the central Philippines in the Sibuyan Sea. And here, after a few minutes, when we recover the ROV, I'm going to show you some of this technology.
My name is Eric Brager. I'm one of the AUV pilots here on board Octopus. And this is the Bluefin 12 made by Bluefin Robotics. It is an AUV, autonomous underwater vehicle. It's basically a robot submarine that flies above the seafloor and makes a map, a sonar map of the seafloor. This is the Bluefin 12. It's split into 3 modular sections, starting with the payload where the sonar is, the energy or battery section, and the navigation and propulsion section. On top is a satellite communications and GPS. And this is the cradle assist before it launched, and we do all of our pre-dives and check out the vehicle before putting it in the water.
We have a little hiccup.
No fishing on that, Scott?
We haven't made it to the double gun, have we? We just saw the one.
We have to go down a deck.
Down the deck?
Yeah.
Down a couple decks. So that platform is for a searchlight.
So we're currently on the main superstructure and the bridge area of Musashi. We are looking at some of the gun emplacements. So is that a...
That's the 12.7.
Okay. So this is the double gun, the Type 89 12.7
Yeah.
centimeter?
The turret roof is lifted off, so the gunhouse roof is lifted off. And this would have been also used as anti-aircraft gun. In her last configuration, Musashi was fitted with 6 of these guns, 2 barrels each, 12 in total.
Okay. All right, let's start pulling back, Paul.
Okay.
Okay, so we're going to get ready to recover the ROV, and we're now going to show you some of the technology on board, the AUV, and that will we'll send you over to Eric, and he's going to explain some of the that equipment. MEC, ROV.
My name is Eric Brager. I'm one of the AUV pilots here on board Octopus, and this is the Bluefin 12 made by Bluefin Robotics. It is an AUV, autonomous underwater vehicle. It's basically a robot submarine that flies above the seafloor and makes a map, a sonar map of the seafloor. This is the Bluefin 12. It's split into 3 modular sections, starting with the payload where the sonar is, the energy or battery section, and the navigation and propulsion section. On top is satellite communications and GPS. This is the cradle it sits before it launches, and we do all of our pre-dives and check out the vehicle before putting it in the water. Octopus has this permanently installed set of technology, which is sort of unheard of, and certainly in the private world and even the commercial world, to have all of the Bluefin AUV and the ROV dedicated for exploration. These are the tools you need, really. It's a wide area swath sonar that can traverse any terrain very efficiently, and a big giant HD camera so you can see exactly where you're looking at down deep. The thing that makes this special and pretty cool is that it is untethered. It is not connected to the ship at all. When we launch it, we let it go, and it autonomously swims through the ocean with an acoustic link to the ship, but no other link at all, so it flies all by itself. So to deploy the Bluefin 12, we lift it up with a crane and bring it outboard the ship, and it gets lowered into the water. And once closer to the water, we pass a line onto a small boat and tows it away. And at this point, the Bluefin is floating on the surface, waiting to get GPS and get its mission program from the operator on the ship. Once the AUV is ready to dive, the small boat takes the line off of it and it drives itself under the water backwards. And once it reaches a certain depth, it flies forward down 1,000 meters under the ocean to scan the seafloor. And once it gets a certain height above the seafloor, it propels itself at that same height, following the terrain. And that what makes it so special is that it is able to map this rough terrain and stay at constant height above the sea floor, and that's important for the sonar image. And once the AEV gets to a certain altitude on the sea floor, it flies at that altitude following the terrain. And it's important to stay at a constant altitude for the sonar imagery. The more constant your height above the sea floor, the better your sonar imagery. So we're looking for stuff proud of the sea floor, like a large hunk of metal. We're not necessarily mapping the terrain, but looking for features on the sea floor. So when the mission is over and we've surveyed after 7 or 18 hours, the AV drives itself to the surface, and once it gets to the surface, after about 40 minutes of driving up, we put a radio link to it, and it tells us where it is, and then we go pick it up and tow it back to the boat with the small boat. And then we hook the crane back up to it and lift it back up. We put it on deck. We hook up a network cable to it and download all the data. And once the data is downloaded to our computer, we scroll through the imagery by hand and look for anything that looks like a ship or debris or wreckage as opposed to rocks in geology. So as the AV is surveying the sea floor, it has a very accurate sense of where it is down to the meter accuracy. So once we get the sonar data imagery, we can mark a position in the image and come back with the ROV, bring the ship back to that location, put the ROV down in an exact position that the sonar image saw, and take more HD, some of the HD video that you've been seeing. These two systems with the AEV scanning wide swaths of the sea floor to find objects, and the ROV take high definition, high resolution imagery, work in tandem together to find things like the Musashi shipwreck. Now let's go back and take a look at the amazing video we've taken so far.
View right now is one of 2 catapults on Musashi. So we know that the catapult was powered by gunpowder charges?
Yeah, for propelling the plane off at very high speed.
And so there's definitely electrical and hydraulic components to it.
Did they point it into the wind with cables, or maybe that was the... like a hook.
Yeah. In that case, this is where they'd load the plane.
Yeah, and Scott, when you come to the nomenclature plate, you can position yourself and zoom in there.
Okay, it's on the other side, actually.
Yeah.
I'm not going to be able to go the full way down here, though. There's an outcrop of steel coming up on the left.
Okay. That'll be good.
So, did the aircraft sit on some sort of a carriage that this thing would propel, or how?
Yes,
do we know how that operated?
We've seen one of the trolleys
Okay.
in the debris field, and it would be rolled up to the base of the catapult on this trolley on these aircraft on the rails that were on the deck, and that's how they move things around. So they had their own little runway system. We've had that one translated.
This one's been translated?
Yep.
So yeah, let's see if we get back on the tight shot and then we'll just look at the translation. We'll hear the translation.
Yes.
Two of them, make sure
That's the
right one. Yeah.
image looks correct.
I thought the one they translate was one of the end.
So this is the instruction plate of the catapult launching procedure.
Reading from the right column to the left. So number one column on the right there would be below pulley box continuous, then release connection between pulley box and dumper. Third column is chute launching gear. Fourth is to electric power device. Fifth is begin point of start stopping. 6 looks to be forward. 7 is act with. Some of these are incomplete because of the corrosion. So it goes on 13 different columns, but it may not make sense to us, the translation, but obviously to people, this is very detailed instructions for somebody operating this.
They do talk about a cylinder, huh? Acting
Yeah.
cylinder.
That's a metal frame. Like a hose. So this round structure is a turntable, so that could move the plane from any one of those 3 tracks that you see, those two lines.
A couple of valves are just underneath the turntable.
And one of the reasons why we're not seeing a lot of aircraft wreckage on the seabed is this whole deck here has been lifted off the ship in what appears to be a magazine explosion, and underneath it would have been wooden ship's boats and these quite delicate aircraft made out of aluminum and cloth, and they would have been blasted quite badly. So that's why we're just seeing bits, and we really haven't seen much of a boat at all.
So some information we received from one of our Japanese colleagues has indicated that there were 5 aircraft on board Musashi when she sunk. The aircraft did carry cameras. They were named K8, which was a Fairchild make aerial camera.
Well, the Fairchilds is the same cameras that the Americans used to take the last photographs of Musashi. That was the K20. So Fairchild was apparently selling
They were.
to both sides.
Well, it says here that it was the copy of the Fairchild, actually.
Oh, right, okay.
So it wasn't actually the Fairchild. It was a copy. 96 generations.
Thing has a pretty distinctive shape you can see in the book. That is a wing.
Oh, yeah, I started seeing the structure, yeah. It's pretty flat in the sediment, so it's hard to tell.
So we sent this image off to one of our experts at Vulcan with the Flying Heritage Collection, and his assessment is that it appeared to be a wing panel, with the exposed structure being a fabric-covered aileron. He said that the wing thickness suggests a jake over a peat. zoom in on that a little bit, Paul?
Yeah. You ready for me to zoom in, Scott?
Oh yeah, now you can see the width of it now.
Yeah.
It's a lot clearer. Leading edge is furthest from us. Yeah.
Yeah.
Okay. Right.
Does that look in focus?
Yeah.
Let me try. Oh, it's that deep. Yeah, it was canvas covered.
If you zoom in right at the lower left edge there, you get a real feeling for the aluminum structure, don't you?
All right, let me zoom back out so Scott can get in a bit closer, and then
Okay.
I'll zoom in.
This is very light, so much lower.
Yeah.
So you want to stay here, and I'll zoom in from here?
Yeah.
That looks good.
It looks like some of the original paint there as well.
Mm-hmm.
Okay, zoom back out.
Can we look at the far end of the wing, Scott? Over to the right? Yeah.
There must be a point where you can get a feeling for the actual fabric. You know, zoom.
Okay, let's get ready to move on. We'll move off to the northwest, off to the upper stern structure. You want to move the vessel, Scott? Or
Okay, and that's, so this is a blast shelter that we're looking at. And they were needed on this ship because when the main guns were in action, the 18-inch guns, the force of those guns being fired such that, they actually could kill somebody. And early in the action that day, some of the men on the deck were blown off. Musashi fired her guns. They couldn't get into a protected area, couldn't get into this blast shelter, and men were lost overboard. So this structure on the right here was where somebody we believe this was an operational area, not just for protection, but they needed that protection as well. To the left of that, the round structure that is quite damaged, and we can't really tell whether that was a gun emplacement or something else.
Could that have would have been a base for one of the catapults?
No, the catapults are further out. This is really the center line of the ship here, and we're looking forward. So if you were in that blast shelter, you'd be looking aft over the crane deck and a central well.
How big is that blast shelter? I mean, like a sense of scale.
Probably two people could sit in there, side by side, very easily. We saw a picture of that. There was a seat.
Multiple rows. There's a good shot, Timmy. Composition there, I think.
So there is actually a door near there.
Yeah, there was.
Yeah. So maybe we could delete those other two things and just note it as Pops' radiator. Okay.
Pull in.
You know,
there.
look, you see that piece of white coral on top of the wheel?
Yep, the one hanging down.
And then look on top of it. There seems to be a fragment of plate there too.
Okay, let's zoom in on this. We'll show him the characters. Oh, keep going. Hang on.
Yeah.
To the left of it. There's
Well,
some on the
both.
wheel as well.
There's some on the wheel, left and right, and then on this plate. See?
Yeah.
No.
No,
we didn't think it was important.
And then over this side.
Alright, and now look, see that fragment on... Oh, you want to show me
I just wanted to show him the edge of the wheel.
Yeah. Open,
Open,
close.
close. And the fragment hanging above the coral.
Yeah, see that? Go up.
Yeah, I see. Right, where the two is touching now.
Okay.
Just a flat painted
No,
surface,
it's just a
isn't it?
flat part of, something has gone on top of it.
So here we are back in the ROV control room. Meanwhile, the ROV is ascending. We're bringing it up to the surface. So here is where we control the ROV. Right in front of me here, I've got Paul Mayer, our pilot. You can see some various screens that he's looking at. Provides him some information about the ROV. And his little joystick there where he controls this. He's got a screen here that actually provides control of the vehicle itself. We've got some sonar up there. We've got some navigational aids. Here in just a minute when the ROV comes up, I'm going to take you out and we're going to look at this technology. Should we go that way? Yeah. Okay, here we go. So here we are in the marina of Octopus. We have our manned submersible Pagoo, and we've got another tender here and our gantry crane. If we walk this way, so you can see right here, here's the winch that has the cable on it that ties the ROV to the ship and provides us all this information. This is how we power the vehicle. It has electric components, it has fiber optics in it, and here's a section of that cable. Okay, we have the copper, there's some fiber in there. Okay. So the ROV is about at 150 meters. She's still ascending. This cable, so if we talk about this cable a little bit, the ROV is on the bottom and it has all these cameras and lights on it. And everything comes up this cable. And it comes into the control room and we provide control, we observe all of our instruments, and then everything gets sent out via the satellite link on the ship. So that's how you're viewing all of this right now. We full speed ahead on that. So in just a minute we'll have this ROV up, and what this is our recovery system. So we'll send this locking device down, we'll latch on top of the ROV and we'll winch it up, and then we'll bring it in here, and this is where the ROV sits. So we'll bring it in, we'll turn it around, and we'll have a good look at it. So in this room we also have some monitoring equipment, so the guys, when they're operating out here, they're working out here either during the launch or the recovery procedure. We've got some instruments up here so they can see what's going on with the ROV, and some statistics. It gives you depth, altitude, some situational information, and we also have the power equipment out here that supplies the power to the vehicle. It runs off of about 3,500 volts. And it's the propulsion system is driven by this electric motor that provides hydraulics to drive this. Let's see, what else? And so right here is the control for the winch. This is how we control either up or down on the winch to bring the cable in or out. Pulling him up. Okay, in just a minute she's going to break the surface. So as we ascend, the pilot is in the control room and he's driving this vehicle to the surface, and we're just pulling in the cable as he's coming up. Okay. What's that? Okay. So Rick over here, he's wearing some insulating gloves, and they're to protect him in case there's any type of an electric leakage out of this cable. because of that high voltage that we talked about earlier. We've got to be very careful. There we go. We're starting to see the ROV. Okay, he's going to start coming down on the gantry. So there's the ROV just coming up to the surface. So we have to coordinate this effort with the ship as well, because we need the ship in the right location and we don't want it to run off from us. So now the pilot is driving the vehicle over to get underneath, position it for recovery. And he's using his cameras and also some instruction from the guys out here doing the recovery itself. There you go. Okay, there we go. We got positive latch on the vehicle. Okay. We're back? Okay, sorry for the little glitch. So we've got the ROV on deck here, and so let's take a look at the camera. This is a high-definition broadcast quality camera. And the way we get these images is via this camera, and we have some systems on here that we have to do some calibrations every time we dive to make sure the color's right and we have the right lighting. And so take a look at the lighting. We've got all of these lights on the front of the ROV, and depending on what we're looking at, we'll turn on and off various lights to give us a better scene. We've got a sonar system right here, and this provides us so we can look out about 100 to 150 meters with us, so we can see objects out in front of us. Here we've got some tracking equipment, and so we know where the vehicle is when it's on the bottom because we get this acoustic signal back from the vehicle. And we have manipulators on here in the event that we need to do any intervention. And so I think that's about it for the vehicle. Let's go this way. So we'd like to take this opportunity to observe a moment of silence for the sailors that lost their lives here at Musashi. On behalf of Mr. Allen and the entire crew of the Octopus, thank you for joining us.